Hello and welcome to the Intelligent Edge webinar series brought to you today by Wind River. This series highlights the innovation that's happening at the intersection of edge computing and AI. Today, we're featuring some standout partners from our growing ecosystem, ZEDEDA and Edge Impulse. Today's session focuses on intelligent safety systems that are reshaping the workplace for manufacturing. Let's begin by introducing our expert speakers. Today we have Sandeep Modvadia, the Chief Product Officer from Wind River, Michael Maxey, Vice President, Business Development, ZEDEDA, and Joshua Buck, Senior Solutions Engineer from Edge Impulse. Sandeep, take it away.
Fantastic. Thanks, Debbie, and thanks everybody for joining. I'm Sandeep Modvadia. I lead product management for Wind River. Wind River, we build mission-critical systems. And so that notion of mission-critical takes all types of different manner of definition. The way we think about it is where it cannot fail. That's where it runs on Wind River. That's what mission-critical means. It's about 5 nines or 6 nines reliability. It's about saving lives. It's about making sure that critical systems required for humanity's general operations keep running. For the most part of these things, when we think about mission critical, it sometimes has a very broad definition. Where we think about mission critical is specifically at the edge, and the edge is really about where technology and humanity, where the physical and the digital world come together. And so as you can see on the screen here, there's really a continuum of different places where the edge comes to life. And obviously, many people have different definitions of what the edge actually is. For me personally, I think about the edge as, again, something that boundary between the physical and the digital world. Now, the edge by its very nature has become very fragmented, and that's okay. And that's a good thing, because what happens and what that means is we have the right tools for the right job in the right places. But because of that, the definition has become a little bit broad. So what we're going to talk about today is specifically when we think about the edge, we're thinking really about this kind of far edge, the place where you can physically touch the device. So I think about that in the context of cars or drones or machinery, places where humans will be physically interacting with those devices in those mission critical environments. So if we move to the next slide, what we start to see here is we're going to highlight exactly what we're going to talk about here. So you see the green highlight here. Again, think about this as being anything that you can physically touch. Most people don't touch their data centers, they don't touch their racks, and even those things may be getting closer and closer to them. They're generally outside of the realms of human contact. And so the scope of today and what we're going to be talking about today is anything that you can physically touch. That's really the distributed edge. That's really the next frontier where AI is going to take place. And I'm delighted to be able to have two of our great partners here, Josh and Maxey, who are going to walk you through some of the case studies we're seeing and then go through the technology that powers them. So with that, I will hand over to Maxey.
Yeah, thank you. Thanks, Sandeep. Great to be here. And I love this case study. It's a super interesting one. So I think it covers what you just talked about, right? It's where the physical meets digital out in the wild. And in this example, what we're doing is we're helping better extract oil from depleted oil wells. And you can see a picture of a truck on the slide itself. So on that truck is running Edge AI. And what's behind that is the ability to really make faster decisions. This particular example, these trucks roll out to an oil well. They sample using a probe out of the well itself, and then can do real-time decision making. And by moving AI from that cloud data center into the edge, which they did about 5 years ago, they really reduced the time to value. So about 95% reduction in time to value. So rather than waiting months to come back and make the changes and optimize the oil flow or optimize the revenue stream, they're doing it when they're there. And this has really changed the way this company runs their business. To them, this is $1 billion algorithm. It's driven a lot of their company's business for a number of years. And over time, they've continued to sort of evolve and change that application, which I'll talk about here in a couple minutes. But we wanted to kind of share a real world example of how they're using Edge AI in the industrial space to really drive not only better revenues, but safety, because often you need to turn these things on and off at the oil well and drive safety around explosives. So this is a great example. We'll have a couple more. Maybe Josh, do you want to do the next one?
Sure, no problem. Thanks, Maxie. My name is Joshua Buck. I'm a solution engineer here at Edge Impulse, and I've been working with Wind River and ZEDEDA to get these edge AI models onto these edge devices, right? Someplace where you're actually taking it from the cloud and then working and training with it to actually be able to physically touch it and work with it out there in the real world. Another case study that we've been working through is industrial safety, right? As you can imagine, there's tons of industrial safety accidents out there in the workplace, right? One study said there's 374 million workplace injuries worldwide, and that's something that's honestly too high, and hopefully something us as partners, us as engineers out there can fix and make a better world. Using AI technologies, using the mass deployment technologies, and using products from Wind River to get them on safety critical systems. So what we've been doing is we've been working together to come up with a solution that solves all these cases, right? Where we're able to, if we could go back to the slide, use Edge Impulse to create these real world models, right? Use ZEDEDA to deploy them onto the targets, and then run them on targets that works with Wind River's VxWorks and Elixir. Right. And the reason why we want to get these on these edge devices and we can't run them on the cloud is that we have to have these models and this software running where we can get lower latency, right? We can work in real time with the systems as they're happening, right? And then at the same time, we get added benefits because we don't have to worry about the privacy concerns. We're not extracting data out into the cloud, right? It stays local and then gets wiped locally right there on the spot, right? And then if we're not having to rely on those network considerations, right, we get improved reliability. And then, of course, we're only sending results, not the actual raw data itself. So we get better bandwidth and things like that out in the field. I work at Edge Impulse. My specialty is working with Edge AI models. So I want to present a little bit about what we offer to this solution stack. And then I'll hand it off to ZEDEDA back to Maxi. He'll bring it to how we get these models back onto devices and eventually hand it back over to Sandeep for the Wind River portion. Next slide, please. So we're going to talk about now, we have these use cases like the oil field industry. We have these use cases for safety critical applications. You need a way to build out these systems. You need a solution, right? And these three companies together has this solution ready. So Edge Impulse is a way to get models onto these devices, right? To build models for these devices. So I'm going to present a little bit about what we bring to the table. Next slide, please. So Edge Impulse is a platform for developing Edge AI models. We can take any data, develop any kind of model for any kind of target, right? What really separates us from our competition is that we're really working with real world data sets at scale. So we're not using generic, research data sets, ones that, you would kind of test things out there, right? We want to work with your data and help you get data from your field to train your particular set of model, right? Develop your own IP, so to say, right? And when we're doing these custom ML solutions, we want to be able to do it fast, right? A lot of the time with ML, it's going to be an iterative process. You're going to have to, get some data, train a model, test, get some data, train a model, test, to eventually get to a place where you feel like you have a very accurate model. And then when we talk about deployment, from our standpoint, we're saying, what kind of devices are you going to work with? These edge devices are getting more and more capable in terms of compute, right? You're seeing a lot of devices out there that have accelerators, from NVIDIA, from Qualcomm, from Nordic Semiconductor, et cetera, Renesas. All these targets will have some sort of accelerator to run these models fast on device. Edge Impulse works with each one of these to make sure that we can have these models run accelerator when they need to be, so that you can get the maximum performance on the device. Next slide. So this is a high-level overview of Edge Impulse. Really what we're talking about here is what we have on the edge device system, so on the kind of top row, and then what we have on our Edge Impulse platform on the bottom row. So I'm going to start with that bottom first. And really, we need to build a high-quality data set. So when we're talking with your data set, we need a way to get that data, from your devices. So we have means to collect data from devices. We have ways to upload into the cloud. You may already have a file. You may already have a set of files, image data, audio data, accelerometer data, gas sensor data, some sort of custom LiDAR data, things like that. If you can get it from a device, you can get it inside Edge Impulse. Once you have that data, you need to be able to train a model. This is a typical ML story, right? Find a data set, train a model. We have a number of models that work for various use cases, from classical ML algorithms to more advanced things for image processing, audio processing, time series data, things like that. And then lastly, you need to be able to optimize that model for these edge devices. Like I spoke before, you need to be able to know which kind of target you're running on, whether it has an accelerator or not, and maybe even reduce the model footprint so that it runs faster, runs smaller, so that you can meet the bandwidth and latency concerns that you have on the device. Once you get it out there and build that model, you need to be able to monitor it. So we've been developing tools for monitoring that model, see if it drifts over time, see how its accuracy performance across the fleet. And then, of course, you're going to repeat this cycle and keep on collecting new data and updating your model. Edge Impulse is a platform that we want you to integrate into your CI/CD systems. So as you're developing, getting new data out there, you can improve your model accuracy over time. Next slide. This is a more simplified view of the platform. And really what I'm talking about here is the steps. Again, I keep on repeating this process of, hey, you're going to have to go and iterate. This is something I actually worked on already earlier this year when we were working for a demo in a better world, where I worked with Wind River and ZEDEDA to develop this kind of workflow. Remember I talked about you have this edge device. In this case, it could be running Wind River Elixir. It has ZEDEDA where you can get the data from the cloud and back into Edge Impulse for model training. Right. And so we collect that data. We're going to design a model around that. And then we're going to do a couple of iterations of testing. But the key part here, I think that this solution offers that's different from others is we have the way to get the model out and deployed onto targets, into a fleet of targets very quickly. When I was working earlier this year with ZEDEDA, we had engineers all over the United States and Europe working on the same model architecture, getting new data, and then deploying out to a system in Italy. And then even at our own devices around our houses and even in the labs and even in the field, so that we can all be running the same model and be synced. And this is something that ZEDEDA brings to the table here, is the ability to deploy not just the optimized model that we have, but to different systems as well. Some had accelerators, some did not, right? And this is something where Edge Impulse and ZEDEDA work very carefully to get some key piece of technology so that we can make that deployment seamless and actually with no code out there for the end user. I want to hand it over to Maxi. He's going to talk more about ZEDEDA, and thank you very much. And we'll have some Q&A at the end.
Thanks, Josh. Appreciate it. And yeah, let's hop into the deploy part of the solution here, and that's really where ZEDEDA fits in. But I want to start with maybe just a quick background on different application types. So on the next slide, you'll see really what's become an evolution of how the industry and how the world builds applications. On the left-hand side are monolith applications. These are really, from the 80s and 90s and still active today, where you're building a complete monolith from the operating system through the database. All of the logic lives in effect one runtime. And this is how we build applications for, the large part of the computer industry up until really cloud came in. And once cloud came in and sort of 12-factor apps and microservices started to take hold, you start to see that middle architecture. And this is where you have generally containers connected, talking to each other, where each container runs a particular part of the stack. So for example, you may have a container that's the database and a separate container that's an MQTT broker, for example. And these work together in systems like Kubernetes or Docker and allow you to bring that full application into an edge piece of hardware, but it does it in a way that allows you to iterate very quickly. You can change one microservice without having to change the entire application. And this is largely how apps are built on, the public clouds and hyperscalers of the world today. And then the third column is sort of the new world with AI coming into these models. So it's still largely a microservices-based architecture, but you're seeing more and more of these AI models show up. And it's generally not one model. It's generally a series of models. You may have a model that identifies things in a video stream, and then a second model that can then take action based on what it identified. We have a great demo that we'll point you to at the end of the presentation here around worker safety. And you may have a model that detects, hey, this person's not wearing a helmet, and then a second trigger that will trigger a real-time action on Wind River to make sure the forklift stops or the safety event happens. So these really need to work in parallel. And then the other reality I would say is all three of these still exist. They all exist at the edge, especially industrial settings. You see a fair number of monoliths, typically running in virtual machines, running alongside these advanced containerized workloads like the microservice architecture and more of these distributed AI architectures. And on the next slide, ZEDEDA was really built to serve all of these, right? We're not just the AI solution. We also could deal with a large number of monoliths. And ZEDEDA is really there to help enterprises and administrators, manage those applications. And these can be managed in thousands of remote locations where you don't have IT people. You often have limited network connectivity. And ZEDEDA is really built from day one. So we support lots of different runtimes, everything from monoliths to AI workflows. We do it through a marketplace, so similar to your to your phone or your Google Android store. You'll see a series of applications that you can really one-click deploy out to many locations and make active right away. And all of this needs to be super secure because remember, these devices are outside your data center. There's no armed guards. There's no locked doors. These often are on a counter in a retail store or behind maybe a locked door at a work site. But these devices also run critical IP for your enterprise. So security is a really important story. And what ZEDEDA does is make it really easy to bring all this stuff together. You select your runtimes, your applications from the marketplace, you deploy them out to these secure devices, you do it in a manner that's really bandwidth friendly and network friendly, and then you iterate over time. Because as Josh said in the previous section, like these models change. We need that full loop to bring data back and update the model and then bring it back to the edge device. So it's no longer the classic IoT where you deploy a stack and then you revisit it maybe a year later or a couple of years later. Instead, these workloads are changing much more active, sometimes weekly, depending on the environment. And that's where orchestration comes in and really makes it very easy for you. On the next slide, we'll talk a little bit about sort of our focus on AI. So, as I mentioned, we run a bunch of different types of workloads, but as AI is starting to take hold inside our customer base, we're seeing they really need kind of three main components to be successful, right? They need the model, which is where Edge Impulse comes in. But once that model comes in, you need these workflow tools to kind of better orchestrate the life cycle of those models, right? So you want to do integration with the tool sets. If you need NVIDIA drivers, for example, you need to have the NVIDIA drivers in place. And as your environment or your hardware or your models change, you need a workflow tool that keeps up with that. And that's something that ZEDEDA can help provide. And then the second component is really around the where do these run, right? And more we're seeing Kubernetes on the edge. We still see a fair amount of virtual machines and Docker containers, but Kubernetes is becoming kind of the de facto container runtime on these edge platforms. And that's where we're seeing most of the AI deployed. They're containerized right next to maybe the data collector, right next to the action, and they're brought together in a Kubernetes orchestration piece, which is where ZEDEDA is super strong. And then the last piece is sort of pulling that model. So Edge Impulse builds it, trains it, has a very nice integration to hand it off to ZEDEDA. And then you need to really config and runtime that. So does it have access to compute? Does it have access to data? Does it have the right networking access? What happens as that environment changes over time? And that's really where ZEDEDA orchestration can bring a lot of power and flexibility into these environments. So these three components really around the workflow tools, Kubernetes, and then the model config and runtime are the infrastructure components that ZEDEDA brings to edge computing. And then lastly, I just wanted to share on the next slide some examples around the type of customers and industries that are really embracing edge AI at this point. We talked about the oil and gas use case and the trucks a little bit earlier in this presentation, but we're seeing edge AI in retail, things like looking at simple things like how long is the line at the cash register, to advanced workflows where you're looking at inventory and doing pre-buying on logistics to make sure you have, for example, the new Nintendo Switch in stock. In the automotive space, we see a fair amount of in-car as well as inside the dealerships, all the way back to manufacturing, optimizing different workflows. A lot of AI is really taking these manual, sort of low-value activities and automating them. That's really the point of AI. It's not about replacing people. It's about making your people much more efficient. And that's happening again in shipping and agriculture, across renewable industries, in the chemical space. Really broad adoption of edge computing and AI going on in the industry right now. And then, ZEDEDA is just part of the solution. We work with great partners. We just learned a little bit about Edge Impulse. We do some work with ServiceNow around, taking action when that model detects something and you need to change in the organization. You can very easily spin up a ServiceNow workflow. But we're super excited about the Wind River component. They bring, as Sandeep said in his intro, like mission critical in real time. And that's especially important in these industrial environments. Edge computing is there because, data is hard to push to the cloud. But this is the next level, right? Imagine a safety scenario where you're detecting people in the wrong location and you have to stop a machine for someone's safety. This is where the real time and the hardened operating systems and all the great work that the Wind River team has done over the years to really bring real time to edge computing and to edge AI. And with that, maybe I'll hand it off to Sandeep, who can kind of dig deeper into some of these great technologies from Wind River.
Fantastic. Thanks, Maxie, and thanks, Josh, as well. So again, as I mentioned before, Wind River, we're all about mission critical. When it cannot fail, that's where we step in. And we really are the platform for those edge environments where you have the most rigorous and demanding of needs, right? So we are talking self-driving vehicles. We are talking planes. We are talking ventilators that keep people alive, or even things like the Mars rover. So that's what I would just keep in mind. And as we think about AI becoming more mainstream and something that we become more dependent on, we absolutely need to make sure that AI remains mission critical as well, right? It's not enough to be able to just solve the problem, but we need to have that confirmation, and we need to have that deterministic behavior that we can consistently solve the problem. So if we move to the next slide, what I want to do is just talk you through our portfolio. The way I think about our portfolio is really across two dimensions. The first is the OT-IT bridge. A lot of times when we think about mission critical, we think about the plane, right? We think about the plane that must take off and land safely. But increasingly, mission critical is being applied to non-life safety critical environments, right? So take finance, for example. Most of the large clearinghouses and trading platforms consider their businesses mission critical. If they go down for even an hour, that could be millions or sometimes billions of dollars of loss and impact. So as we think about mission critical is no longer just about OT or IT. It's not about edge or cloud, embedded or enterprise, specialist hardware, commodity hardware. Mission critical happens absolutely everywhere. And the way that we enable mission critical is a combination of platforms and tools. We have platforms that scale down from the smallest microcontrollers all the way up to the largest cloud, private cloud environments installations, and then tools that follow the life cycle of the application. And so the way that I think about this is platforms give you the assurance, tools that help you reduce the TCO to make it practical to run, because we know getting up to 6 nines can be expensive. So we want to make sure that we do this in the most cost-effective way possible. So our tools continuum starts at kind of develop. So you build your application, you got to test your application, you want to manage and deploy it, and then finally monitor. And it's that combo that allows us to really deliver on that promise of mission critical. So let's move to the next slide. As we think about this powered solution, the thing that I always like to consider is that we are an ingredient. Wind River is not the final solution. We are only as good as our partners. And as we've been building out these solutions for industrial and manufacturing and others, we're very proud to be one of the ingredients along with ZEDEDA and Edge Impulse, where we can bring our stacks together across the silicon level, across the OS, the orchestration, and then finally the AI models to actually have a consumable end solution for our customers. And I think that's the thing that's the differential when we speak to our actual users, is we don't want to come to you and say, hey, we've got an ingredient over here and you need to figure out the rest of the problem yourself. Like, we collectively have solved the problem, and we will collectively come and help you together to be able to create that right business value and solve your problems. So again, big thanks to Maxie and Josh, ZEDEDA and Edge Impulse for all the work that they've done with us. We're very excited, not just about the partnership, but about the solutions that we're actually building, how they're complementary, how they're solving real world problems, and more importantly, how we can actually show them to you today. So with that, we'll move to the Q&A if there's any questions, but I'd like to thank you again. And here's our primary contacts. If you'd like to be able to learn any more, please reach out to Walter, Maxi, and Josh. They are the true experts. They know this technology inside out, and we're all very excited to help you.
Thanks, Sandeep. It looks like we did have a couple questions. Maybe the first one, and I'm happy to take a swag at it, but the question was, what architectural challenges arise when combining AI workloads with microservice orchestration at the edge? And maybe because the word orchestration's in there, I'll jump in, but would love Sandeep, Josh, you guys to weigh in as well, because you have very different perspectives and great input here. So, I think fundamentally edge means constrained, right? And that's one of the first architectural challenges you have to think about. In the cloud, you can burst, you can spin up another EC2 instance, you can add more data, you can build your bigger database. This is a lot harder when you're on a constrained device at the edge. It takes a physical visit, it takes more hardware. So you need to think about an architecture that satisfies not only for today, but for the future to some extent. And that's always a bit of a cost trade-off, because you don't want to buy, a too expensive a machine, because you're putting these in thousands of places. But you also don't want to constrain your future by doing something that only supports today's workload. You have to assume your models are going to evolve. You have to assume your applications are going to be refactored, maybe from a monolith to a microservice style architecture. So one of the challenges around managing AI workloads at the edge is the constrained nature of it. And that's really, I think, where my partners here, technology really takes off. Like they've been built for these types of workloads. And Josh, maybe jump in on how models can be better architected for the edge.
Exactly. So thanks, Maxi. He absolutely nailed it on the head, right? If you're working with an edge device, you're dealing with constraints of some sort. And not only that, you have a wide variability of the types of devices that you can work with. Some are very, very constrained. Some are practically servers that are just happen to be edge device that they're just calling edge, right? And when working with AI workloads out there, you want to have a system that is able to take advantage of the compute in the most reasonable fashion. Okay. So as I mentioned earlier, you have devices out there that may or may not have accelerators, AI accelerators. And if you have a solution that can be cognizant of that fact and says, okay, hey, here's a model that can run accelerated, doesn't have to run accelerated, but we'll take advantage of the accelerator when it's present, right? If you have a solution for it, that's what Edge Impulse brings. Okay, so you can still use the orchestration component that you have from ZEDEDA and an underlying OS like you have from Wind River, and then you can just be cognizant. You can be almost agnostic to the architecture that it's actually being deployed on, right, in terms of the chip, because the system can go and say, okay, hey, I have an accelerator of this type, therefore I need to download this particular set of model binaries so that it runs in the most efficient way. And so this is something where, we have taken and removed that architectural challenge and brought it into us to take advantage of and to work around, so that you as a end user, end deployer, doesn't necessarily have to be fully cognizant of all those kind of things. You just have to generally know what's in your fleet. But you don't need to know exact particular devices, because we can deploy to, ARC64, ARM devices, Intel devices, NVIDIA devices, Qualcomm devices, right? And make sure that they all can run accelerated when they need to. And so that's part of the orchestration component that we help bring into the solution and that we offer together.
Yeah, and then maybe like the other sort of vector to think about is kind of the criticality of the response, right? So you think about mixed criticality workloads. Is a 1 second response okay, or do you need milliseconds of response? And Sandeep, maybe weigh in a little bit around how the Wind River different platforms provide everything from hard real time to kind of edge real time, and how that maybe should think about your architecture around that.
Yeah, absolutely, Maxi. I'm actually going to build off something that you said before, which is the first thing you have to think about is you have those swap restrictions, right? Space, weight, and power. And that's something that is paramount whenever we think about any type of critical edge AI workload. I think where things get challenging, and these are things that we are able to solve real well, is how do you make sure your AI models then behave in a deterministic way? Right? And that is literally a contradiction in terms. Like AI by its very nature is unpredictable because you need it to be able to respond in real time. At the same time, you want deterministic behavior within your platform. So there's things that we can do to make sure that you can say, okay, great, how do you, and you referred to it before, like, if we're having things like mixed criticality or you have robust partitioning, how do you make sure that your AI model can operate independently, but you can put some deterministic bounds around it so that it doesn't take the full system down, right? And that's one of these things that starts to get a little bit trickier when you're dealing with something that is inherently and deliberately unpredictable, especially when you want some level of control and you have these constraints that are placed upon you. And so these are things that we build within the OS to make sure that we have the right hooks and harnesses so that you can allow the model to do what it needs to do, but you still have some level of control and the ability to corral it as needed so that the model itself operates within the right parameters of the system.
Yeah, and I think the good news around all of this is partnerships like these make it easy, right? We've built the right integrations. We've done this for other environments. And it sounds like there's a lot of architectural considerations, but fundamentally, that's where we're here to help, and that's why technologies like ours are super valuable. Debbie, do you want to bring in for the next questions?
Yeah, I just want to make sure that we answer and address the very last question, which has to deal with low latency. So what do we do to optimize models from a low latency perspective for inference at the edge? Is there somebody that, Josh?
Yeah, I'll be happy to take that one. So Edge Impulse really helps in this situation, right? Because we are a platform designed for edge devices, not cloud, based model of running. So we always bring in models that have this low latency, low space, low RAM, low flash, kind of constraints in mind. And that's something that we try to train for on the platform. So we absolutely do things like model quantization, right? Typically we'll train at least a float 32 model to try to get the best accuracy. We can then quantize to an NA or a hardware specific quantization scheme. It depends on the accelerator, and show off those accuracy numbers so you can make determinations about what kind of ways you may need to work with the model to retrain it to help improve that accuracy. Even some frameworks have actually offer QAT quantization aware training, and we can take advantage of that when needed. In terms of other aspects that this question had in terms of like model pruning and model distillation, those are things that are kind of dependent on the particular model and the architecture they're working for. If the accelerators are good enough, you don't have to prune because they can just run really, really fast, right? We're not doing LLMs models typically on these edge devices quite yet in terms of the platform. That's something that we've been working on. We demonstrated that at Embedded World this year. But in terms of these other vision models and these other audio models, they work really great on the existing accelerator sub-second, sub-milliseconds, tens of millisecond type performance for what you need. But if you do need to prune, that's something you can do inside the platform as well. And try to make your model more optimized in that case. Let me bring in a product that we have or feature called Eon Compiler. So if you are working with TF models, we can actually optimize those models even further for RAM and ROM constraints, where we work with the TF-Lite graph to make it more optimized and run faster on those devices. In terms of model distillation, learning distillation, we do a lot of things like transfer learning in the platform, right? So we can take start from a pre-trained model and work out that way, and try to make it, where your training's a little bit more efficient, right? So you're not starting from scratch, you're not starting from a blank model as well. And then we're even exploring ways to use, cloud models in terms of that to help us train, models for edge devices, right? So this is a great case where you can use synthetic data and, generate, data sets that are specific for edge cases, right? That you may not have a lot of data for. So maybe you can even augment some data, take a pre-trained model, and then tune it for that particular edge case and deploy on device, right? So something that may be novel and unique to your particular situation, where there's just really no data for out there in the real world.
We have one final question, great one around security, which I know is always a concern. What are your security mechanisms for edge microservices processing sensitive AI data, example, biometric video? Is there anybody that wants to take that?
I mean, I'll jump in from the infrastructure perspective, and then Sandeep and Josh, feel free to weigh in on that. I think security is a full stack question. It's not just about the data itself. It's the device, it's the network, And the mechanisms for that are pretty well known. If you think about kind of the device and the operating system, you're using techniques that are popular on mobile phones, right? If you have an Apple phone, it has a secure enclave, which is a piece of hardware that is a secure place to store your keys. You're measuring your operating system to make sure nobody's inserted a bootloader underneath it. You're typically running, a firewall or a commercial security solution to handle some of the networking and application level things. So there's a whole security stack and a whole industry that we're bringing into these edge workloads. And then on top of that, there's mechanisms for the data itself and the model itself. I don't know, Josh, if you want to kind of weigh in on how you guys think about model security.
Yeah, so Edge, by the nature of what we're trying to work for, since we're not trying to deploy or bring data outside of the Edge device and back into the cloud, you already have a great secure kind of element there, right? And then we can take advantage of these secure enclaves when you build the applications, when you build the models, right? Where you can partition off the space and only, regulate it to certain user processes. Those are something that we can work through as well when we're building out a particular set of solutions. It's not just the microservice out there on the edge too, it's the whole platform, right? So when you're training the model, when you're training the data, you make sure you have a secure platform. Edge Impulse is SOC 2 compliant, right? We work with HIPAA data, things like that, so that you can anonymize what you need to train, so that we don't have, personally identifiable information, and make it very generic. And so that way you're not, leaking data out there in the cloud. Especially when you're deploying back on the edge, right? You make sure that you have, a great model that's only running on that device and doesn't need the network connectivity once it's running. Obviously, you need a way to get it deployed there, right? You need a base OS. That's why we have ZEDEDA and Wind River today. But in terms of security, you have to work within the hardware framework that you have already and run within the software frameworks that you have within the systems to run secure.
Great, thank you.
The other thing I would add from an OS perspective, we don't look at the data, right? In fact, we run in some of the most restricted and governed environments out there. So we don't even have any telemetry collection within our products. So we don't have the ability to say, yeah, we treat AI sensitive data, AI data differently. What we do have is a rigorous set of security standards that we have to adhere to, again, because we work with a large number of government and defense agencies, and they put our processes and our product through the ringer, all the way down to security code reviews, to make sure that we don't have vulnerabilities, and so therefore the platform is as secure as it can be. And we also a CV authority ourselves, and we take security very, very seriously to make sure that we have the most hardened and secure platform possible, so that when you're running your apps on there, that's one less thing to worry about, is the platform itself creating another vector of attack.
Great. And with that, on behalf of Wind River, I want to thank our wonderful partners, ZEDEDA and Edge Impulse, for joining us today for the Intelligent Edge webinar series. If you are interested in digital transformation of your manufacturing floor, of your industry, please take the time to book a demo with us. We'd love to talk to you and provide any expertise we can along the line to help you advance your manufacturing floor. With that, thank you so much for joining us today. That concludes today's webinar.